In this module, we're going to talk about the config database, contents thereof, and it's a bit tough to talk about the config database without actually having an example to show you and to work with. So, similar to the RepelSet test constructor that we used earlier to create our replica set for testing, I'm going to show you the equivalent for a sharded cluster. And we start off by firing up a Mongo shell with no database, as before. And this time, what we're going to do just create a cluster. So you can actually assign any variable here. I'm just using the variable cluster because it's descriptive. There's no need to start the cluster or initiate the cluster. It'll actually all be done for us. So as soon as we run this, it will start kicking off the various different pieces that we need to create a sharded cluster with 2 shards. We're going to set chunk size to 1. The default is 64 megs. That'll do 2 things. One, it'll make splitting chunks and migrating chunks a little bit easier. And it will also give us something in the settings collection, which we're going to look at later on. We're going to use 3 config servers, which you should always do in production. We could just run 1, but we're going to run 3 just to sort of keep in track with the principles of this course so far. And then the final parameter I'm passing in here is the other options, and I'm just going to pass in rs true. And what that says is replica set true, in other words, and that tells this constructor to use replica sets for each shard rather than just say a standalone MongoD instance. So if we hit this, that's actually now completed, but the messages are going to continue to scroll by. We'll open up in a new tab, and this time we will connect to port 30999. That's just previous experience. I know that's what the Mongo S will start up on by default. Let's have a quick look at what this test shard looks like that we've just set up. So sh.status tells us that we have 2 shards, test-rs0 and test-rs1. They consist of 2 hosts. That's a loose term. So here's test-rs0 running on education.local 31100. The secondary is running on education.local 31102, and there's another secondary on 31101. Here's the second shard, test-rs1, and you can see that's running member nodes on 31200, 201, and 202. So to take a look at the config database, it's as simple as typing in use config. Let's have a look at the collections therein. So we can see we have changelog, chunks, databases, lock pings, locks, MongoS, settings, shards, system.indexes, and version. Some of these are more important than the others. Some of them are going to be empty at the moment. We can do things to fill those up, of course. Let's look at the one we've already mentioned. So let's have a quick look inside settings. Not much going on inside the settings collection here. Just the one setting that we've passed in so far, and that is chunk size, which has a value of 1. So that's a 1 meg chunk size, and as I said, normally that would be 64, but of course if it's set to the default values, it may not actually be populated in here. Let's take a look at the MongoS collection, what's in there. So the MongoS collection is going to contain any MongoS processes that have connected to this config database. In our case, there's only going to be 1. This may vary in your own sharded cluster. If you've got multiple MongoS's, maybe some of them haven't connected yet, maybe some of them have been lying dormant, maybe just some of them haven't connected in a long time. This output is going to vary depending on which config server you look at, that kind of thing. But for us, there's only 1 MongoS, so there's only going to be 1 entry. And you can see there's some information about it in there as well. So far, so good. Now, the changelog, the reason why I've run the stats command on this particular collection is you can see that it is actually a capped collection. So that's what this value in the stats command will show you, that this is capped. And you can also see that at the moment the size is 480, so it's 480 bytes, not very large. But the storage size here, that is 10 megs basically. So it's a 10 meg capped collection. There's not much in it at the moment because we haven't done much with this. You can see that there's been some upgrading work done here by the MongoS when it connected, upgrading the config database from 0 to 4. Actually, I think that's just some standard maintenance at the start. I think there's actually anything particularly wonderful going on there. So just 2 entries so far, not a terribly active changelog at the moment. Anything else that we make this cluster do should show up in here shortly. So let's go back to our collections listing. Now chunks seems like it might be an interesting collection. So let's have a quick look. There's nothing in there. The reason for that is we just started this up. So we haven't actually created any sharded collections. We haven't created any sharding enabled databases. Let's see what databases tells us. Databases tells us that there is actually just 1 database that it's aware of right now. It's called admin. It's not sharded. That's what partitioned false means. The primary for this is the config database. We're going to get into exactly what this primary designation means. It doesn't mean primary in the replica set sense. It's actually a different use of the term primary. But we're actually going to do this as part of an authentication and security section later on. So I'm just going to leave that as the primary database for admin is the config database and just leave it at that for now. We'll get back to exactly what the implications of this primary field are later on. db.locks has got some stuff in here. This is just stuff that the MongoS has been doing. You can see it's tried to kick off a balancing round, hold a balancer lock. Again, we'll be talking about how that actually works later on. So there is an initial population of the various things in here. The main meat of this will only be apparent once we've actually done something with this sharded cluster. So one of the things the eagle-eyed amongst you might have noticed, if we do show collections once more, is there's nothing in here called actually collections, which is a bit surprising, right? Since you shard based on the collection itself, you'd expect there to be some sort of metadata about the collections, how they're sharded and where they live and that kind of thing, and that isn't done here. So that's one of the things that's going to be added to the config database once we've actually created a database, enabled sharding, and then sharded a collection within that database. So we'll go through that and just do that now. The first step is to use a database. I'm going to call this one shard test, enable sharding on shard test. And what we've done now is we've sharded that collection, shardtest.foo, the one that we just inserted this single document into. I've used the _ID field as the shard key in this example. That's the second argument that I've passed in to the shard collection helper. And although that is generally a bad choice for shard keys, which was explained by Dwight, the default contents of an _ID field are an object ID, and an object ID is monotonically increasing over time. It contains a timestamp as its leftmost bits, essentially. That can be a poor choice for shard key, but for testing purposes, it has the advantage of already having an index. So normally, say if I'd wanted to shard on the A field here, I would have had to have first created an index on the A field. So for some shortcuts and for testing purposes, creating a sharded collection with an _ID shard key is acceptable. The final piece that we'll actually do is insert some data. We will go with 100,000 just to see how that works. They're going to be small documents, so we may not breach our chunk size, but let's have a quick look and see what happens. There's our sh.status now that we've added some data and we've actually sharded a database and things like that. So sh.status is just a helper. What this helper actually does is it just runs a little MapReduce script over the config database. So it's pulling this information out of those collections we were just looking at. We'll go back in and see what the changes are like right now, but just to give a quick overview, we've still got the shards, as we'd expect. And now here in databases, we have this shard test database. It is partitioned true. Again, it has a primary field, and we're going to go into what that is a little bit later on. You can see that our inserts did do the trick. So we have shardtest.foo. There are 5 chunks. There's the min and the max chunk and 3 chunks in the middle. And that should give us a decent amount of content in our config database. So let's go back in there. Let's have a look at db.chunks.find. We do indeed have content in our chunks collection. There should be 5, in fact. So let's really quickly just count those. And there are 5, absolutely. This is basically the sort of raw version of what we're seeing in sh.status. Let's see what else. Collections, show collections. There is indeed a collections collection listed there now. So let's see what's in there. Just the one. We have just one sharded collection to speak of. Let's use a find one to give us the right type of printing here. Its ID is the namespace, so shardtest.foo. You can see when it was last modified. It hasn't been dropped, so when you drop a collection in a sharded collection, this would be dropped true. It doesn't necessarily get rid of all of this information immediately, so you'll still have an entry in here from a previously sharded collection that has been dropped. It gives you the shard key, which in this case is _ID. Unique false, so we have an enforced uniqueness there. And just some last modified information about the collection. And what else might have changed? We mentioned that changelog is recording what's going on, so the changelog should have some, previously just had 2 entries. Let's have a quick look. Let's count them. There are now 11 entries in the changelog. If we have a look at them in a more readable manner, what we'll see is there's a migration in here. There'll be several entries for each migration, but what we're seeing here is that this is the move chunk.from piece, so this is where it's being moved off of its original shard. The minimum for this is this object ID, and the max is the max key, right, which is a sort of a meta value that will always evaluate to greater than whatever you're measuring it against. So this is the maximum chunk or max chunk that's being moved here. These various stages indicate how long each piece of the migration actually took. We see that the next thing in the changelog is actually a split. In this case, we split the max chunk. So before it was this, and then afterwards we have a min and a max of an object ID, and the other chunk, if you like, has a min of an object ID and the max again of the max key. You've taken the maximum chunk, you split it in two basically. And again, there was another split, so we split the max key again. You're going to see this a lot because of our choice of shard key, in fact. Because we picked a monotonically increasing shard key, all of our writes will always go into this max chunk, because this is always increasing. So if I were to kick off another round of inserts, they would all be greater than this value. Therefore, they would all go into this chunk. Therefore, this is the chunk that is going to then be split when it reaches our max chunk size. As we add data to this maximum chunk, this is the one that's going to keep getting split. This is the one that's going to increase our chunk count, and that's also the reason why picking a monotonically increasing shard key is a bad idea, because all of your writes will always go into this one chunk, which means all of your writes will always go to one shard, and you've essentially limited your write capacity to a single chunk, which can only reside on a single shard. And the final piece that we're going to cover here, we're not going to go through all of the individual collections, we're just kind of picking out the ones that are sort of interesting. And one of the things that I mentioned to you before is that all of the config databases are supposed to be identical. And in fact, there is a consistency check done on a regular basis to make sure that all of the config databases are identical across the config servers. But not all of these things are going to be checked, right? They're not all required. For example, it doesn't matter if the changelog is different on each of the config servers. That is not vital to the operation of a sharded cluster. So what is vital to the operation of a sharded cluster? Well, let's list those out. The 5 collections that are checked across the various config servers for consistency are chunks, databases, collections, shards, and version. The rest can be different, and it is not considered a problem. So all those other things like even settings, changelog, they can all differ, and that will not throw an error. But if any of these 5 collections do not agree exactly, and in fact the way that this is done is internally inside MongoDB, we compute a hash for the total contents of each one of these collections and make sure that the hash value that's returned is the same on all 3 of the config servers. You can think of it as a hash is computed and compared. If any of these are different across the config servers, the MongoS's will start throwing errors, refuse to start until that is resolved. That is what is checked for consistency. That's how the MongoS's know that all 3 config servers are actually in sync and in a good shape. Never update the config database directly. Unless you're talking to one of our engineers and you're expressly asked to do so, don't do it. For any of the normal operations that you're supposed to have update the database, there will be helpers such as sh.enable sharding that we ran earlier on. Those are what you should be using to make changes to the config database. If there is something that you need to change on the config database itself, even if we're asking you to do it or it's something that you need to do as part of a maintenance, always do it through the MongoS. The reason for that is the MongoS knows how to talk to the config databases in the correct way to make sure that that 2-phase commit protocol we mentioned earlier actually occurs, that they're all kept in sync, and that if it fails, it won't actually do the write. So always do your updates, if you must, through the MongoS, and for anything that you're doing sort of a regular basis during normal operations, there should be a helper of some sort for it. You shouldn't have to go in here and actually make direct changes to those tables. But if you do it through the MongoS. Do not connect directly to the config servers themselves.